Today we're going to have a quick lightning talk about Oracle security. Before we jump into Oracle security, we had like a really nice introduction about Chaos Labs. I'll elaborate a bit further about what we do, and then connect our work to the content of this talk, which is securing data for DeFi applications. So at Chaos, broadly, we exist to secure and optimize financial applications on-chain. We've been around for over 2 years. Today, we're lucky to work with some of the largest DeFi protocols in the world. So some of our partners and clients include Aave, DYDX, Chainlink, Uniswap, Curve, Osmosis, Avalanche, and more. Now, on a broad level, when you think about security in Web3 and for crypto applications specifically, the security model is very different than what you'd be familiar with if you're coming from a Web2 background. Usually in Web2 backgrounds, you have complete control over your application, the environment in which it's running. You have permissions, who can interact with which endpoint, at what time, to what capacity. And typically in DeFi, all of this doesn't exist. So we have a bunch of external, we can call it like stimulus or application input, which definitely dictates the state of your application. So one thing which is mostly what we're going to focus on today is oracles itself. So we think of oracles as these robust services that write data on-chain, when in reality they're much more than that. They're directly responsible for what state your application is going to be in. So if you're a lending venue, are liquidations happening right now? Well, that depends on what the oracle is saying. If you're a perp exchange, is somebody in the green? Is the P&L positive? Or are they losing? Well, that actually depends on what the oracle is saying. We think that an oracle, because of its namesake, is always reporting the most accurate, precise, up-to-date data, but that isn't always the case. More broadly, when we take like a step back and think of everything that goes into security, we have like the stack here, which I think most people know about, audits and maybe penetration testing, some type of runtime verification. And here today, we're again going to hone in on this notion of economic simulations and Oracle security. So let's start with the basics of Oracle security. We're at SmartCon. This should be a refresher for everybody. But the first thing that we want to talk about when we speak about oracles is levels of decentralization. So at the most basic level, this isn't great. This doesn't use any of the benefits of Web3, but unfortunately it still exists today pretty prevalently in large DeFi applications. You have a single server controlled by a single key and a single developer that's writing data on chain. I won't go into specific examples, but I think every few months we have reminders of this when certain services go down. So this is just from a reliability and redundancy perspective, you have none of it because you have a single server which is responsible for writing the data. It's fully centralized. And the accuracy and integrity of all of your application's data is at the mercy of a single developer and or cloud provider. So even if you're an honest developer, you could be on a Google GCP, and they have an outage in a region, and your users are going to get hurt by that. Now let's look at something that's a little less trivial. So we have developers that say, okay, I care about my users. I want to do my part in ensuring that this is an application that has high standards in terms of the data reliability and redundancy. It's still going to be me or my team that's going to run everything, but instead of a single server, we'll deploy in multiple. And take that a step further. We want even more redundancy on the cloud level, so we'll deploy to multiple regions. Okay, so now you have 1, 2, 3 N servers that are controlled by the same entity. We do have some level of redundancy. So if there's an outage, if something goes down, if a service crashes, we may have a backup for that. But we're still centralized here because this is controlled by a single entity. And we're at SmartCon, so we'll definitely talk about the Chainlink Dawn, but this is just an image which illustrates a larger idea. Instead of having all of the data controlled by a single entity, we have a decentralized network of Oracle nodes that are running. They're all sourcing the data, ideally in a different manner, submitting it to an Oracle, which runs some type of medianization process to get to the end result, which is, in most cases, what is the price of this asset. So here we have redundancy. We have independent operators. And in order to really kind of hurt the users of the network, you need node operators to collude to be dishonest. There are kind of different ways to go about this. One of the most straightforward one is staking. So node operators stake some type of economic value. And if they are proven to, or via consensus found to be dishonest, they're slashed. So there's an economic, I guess, incentive to be honest at all times. But here it's actually just important to always maintain that the price of corruption is much larger than the corruption payoff. Otherwise, it's worth it, and we're waging into a territory here for attackers or would-be attackers doing risk management, trying to understand what the P&L is on a certain attack. A quick aside, this is part of the work that we do at Chaos Labs. So for all of the protocols that we partner with, we build models that, that estimate the price of market manipulation, and we really try to assign numbers to this formula of understanding what the price of corruption is and ensuring that the payoff is smaller than the manipulation would take. Now, really, like when you think about decentralized Oracle networks and Chainlink, we always speak about the decentralization and the node operators and maybe the staking and how you can get slashed. But what we're really talking about here is decentralization, and then on the redundancy side, kind of network security, ensuring that your data is always getting delivered on time. Something that is usually spoken about much less is data latency, precision, and resistance to market manipulation, right? I think like most people who are consuming like a highly liquid price feed for Ethereum assume that the price is accurate always. Well, let's see when that precision, or when more precision is actually needed, and when not having those kind of measures and layers of market manipulation, resistance, and latency can hurt us. Now, even though it's less spoken about, I think it's something that it sounds kind of obvious. So people say, like, why are we speaking about this now? Chainlink oracles have been around for a long time. This is kind of a solved problem. So for kind of the V0 of what we just saw in the last few years of DeFi, where the most prevalent application were spot market trading and borrow and lend, precision and latency were important, but the way that we see it, this past year and the next wave of DeFi is actually a moment of truth for Oracle performance. And the reason for that is really the introduction of DeFi derivatives. So when we're looking at DeFi derivatives, kind of different than their more, let's call it, primitive borrow lend or spot market counterparts, you have perpetual leverage trading financial instruments. And because of the leverage and because of the perpetuality of the instrument, this completely magnifies the importance of precision and latency. So any directional trade impact, depending on the leverage used by a user, completely amplifies any lack of precision reported by an oracle. So let's really hammer this home. Let's get less abstract. And to give an example, so Alice is trading on a new perpetual protocol that's called new per protocol. They promise sex-like trade execution, which is great and innovative, and it allows leverage positions across various assets. What an astute attacker is going to kind of look at for an oracle attack of this manner is he might start by looking at the latency of the oracle, if the oracle is naive. So let's say that the attacker realizes, hey, the oracle that the application is consuming is about 15 seconds after what I'm seeing on the most liquid sex market, let's say Binance. And Bob sees that Bob, the attacker here, that because of this latency, they know the next Oracle price report with high accuracy. So if you know what the next Oracle price report is going to be, one of the classic vectors for extracting value out of the application is front running. So Bob sees this, opens up a highly levered trade, knowing what the next price is going to be. And this is a case of an informed trader that drives loss to all makers and LPers if we're using a pool model here for the perpetual exchange. Now, just to put some numbers to this, Binance is reporting Ethereum at 2K. Bob sees the next price at 2010K USD. During the gap between when the price is observed on Binance to when the price is reported on chain, he opens up a $10 million USD 100x long position with a 100K margin, and his P&L is in a single block netting 50K USD. Now, let's look at the takeaways. So historically, when we think about borrow and lending protocols, if this was possible on a borrow-lend, front-running a 1% change could either yield no return or 1% return maximum without leverage. But with leverage, a 1% change can net an attacker 100%. With flash loans, capital requirements and attacker risk is further mitigated and reduced. Now, there are different techniques for mitigating this. Actually, Chainlink is on the forefront of employing them. So one of them is this two-step signing process, and the other is the low latency Oracle, which ensures that the latency meets a certain SLA and doesn't allow naive attacks like this. For the solutions, feel free to come and chat after the talk. Now, really, this is all great in theory. We saw an example, but it's actually graduated to theory. So this week, GMX adopted in production the Chainlink low latency Oracle. This was a project that Chaos Labs worked on over months with the Chainlink and GMX team. So now we've graduated from theory into tangible tools for developers in production. Now let's run through another quick example of market manipulation. Here it's very, very important to differentiate between Oracle manipulation and Oracle failure and price and market manipulation itself. But let's say that this new PERP protocol derives asset pricing using a naive volume-weighted formula from top venues. So Bob, the attacker, creates a service to kind of observe deviations from the price reports and can kind of see patterns. So very quickly, Bob starts charting out. He does a time series of prices on Binance, Bitfinex, Coinbase, Kraken, OKX, and he sees how they differ relative to the price being reported. Now you can see some trends here. In this graph right here, Bitfinex is the highest. So it looks like for some reason, the prices quoted on Bitfinex are a little bit amplified in comparison to the rest of the trading venues. He does this even further, samples the DEXs samples the SEXs for a longer period of time and gets confident with his results. Does a little bit statistical analysis and is convinced that with some starting capital, he has a pretty high probability of getting a positive return if he wages some type of market manipulation attack. And this cues us for the example. So new PERP protocol is super innovative, like a lot of PERP protocols claim to be today, and they offer PERP markets for low liquidity, long tail assets. Bob says, perfect. I know how prices are calculated because I've done this statistical analysis, and I have pretty high confidence here. And I'm going to look for the venue here, which has the lowest liquidity, and pump the asset. So first, what Bob does after he gains his conviction is he opens up 100x long on a low liquidity asset, pumps the price. Bob is in the green, and he's a happy camper. Using statistical techniques, he had pretty high confidence that this was going to work. He waited for the right asset at the right time, pumped the market, and closed his position. We're running short on time here, but this will be available for whoever wants a little numbers to draw intuition. Now, again, this type of attack isn't theoretical. I also will refrain here from naming names or things that we've seen in production for the sake of the protocols that are alive today. But this is a type of price chart that you could see from an Oracle that has a market that's being manipulated in the background. So really what I want everyone to walk away from today is understanding that oracles are critical for application security. You think of a security audit, you think of pen testing, you think of CI/CD. This is just as important. There are a ton of vectors, most of which we haven't even discussed today due to this being a lightning talk. We actively research these type of security vectors, vulnerabilities, and exploits. We work closely with Chainlink and protocols to mitigate them. And it's important for me to also say that while best practices are definitely needed and should be adopted, context is king for your application security. So there are no silver bullets. Novel financial instruments introduce novel attack vectors, and you should be thinking about this before deploying to production, drawing TVL, and going live. So we always say bad risk parameters or bad risk methodologies are and always have been attack vectors, and I need to end it with a meme. If you're interested to talk about this, I'm here today, and the team is available. That's my Twitter, and you can reach out on the website. Thank you, everybody, and enjoy SmartCon.